Like I said, you guys will be able to identify and use properties of special right triangles. We're starting section 7.2, okay? I don't anticipate finishing it. If we do, that's a bonus, but I don't anticipate that. So, special right triangles. We have 6 triangles up here. Now, what do we know about triangle 1? It's a right triangle. We have a right angle. It's isosceles. There's 2 congruent sides. What are the congruent side lengths? 3. Hey, do we notice this pattern where all 6 are isosceles right triangles?
I do.
They're isosceles triangles, 2 sides congruent, and they're and they're right triangles where there's a right angle. Now, what can you do with the right triangle to find the third side if we know 2 of them?
Use the Pythagorean.
Pythagorean theorem. Here's what I want you to do. I want you to write down in this table the length of a leg in number 1. So in this case, for triangle number 1, what would the length of a leg be? 3. I want you guys to use the Pythagorean theorem to find in simplest radical form the hypotenuse for number 1. I want you to do the same thing for 2 through 6. The radical form is where you go through your radical and you simplify it, like we did in the last section.
Oh, goody.
So like this times the square root of this. I want you guys to do all 6 of these Pythagorean theorems. On number 1, if we were using the Pythagorean theorem to find the hypotenuse here, we'd say 3 squared plus 3 squared equals our a squared. In this case, it's kind of weird to have a as the hypotenuse, but it's called a. So then we say, well, 9 plus 9 equals a squared. 18 equals a squared. And how do I undo that square on the a? Square root both sides. And so I have the square root of 18 equals a. And then I go through the simplifying radical process, just like we did in the last homework assignment, and say, hey, what's a perfect square that goes into 18? 9. And so I can say, hey, well, this is the square root of 9 times the square root of 2. So it's really 3 times the square root of 2. And that's what I'm going to be putting in my box. Okay, so go ahead and continue working on this. What was the leg length on number 2? 4. What was the hypotenuse on number 2? 4 times the square root of 2. What was the leg on number 3? 5. What was the hypotenuse? 5 square root of 2. What was number 4, the leg? 6. What was the leg? Hypotenuse, excuse me. 6 square root of 2. What did we notice about these guys? There's a pattern. What is the pattern?
If the leg is basically the hypotenuse, then you add a square root of 2.
Do you add a square root of 2? You multiply by a square root of 2, right? Add would be kind of like the slang term. You add it at the end, okay? And so we had 12 and 12 square root of 2. So the pattern we notice as we go through and do the Pythagorean theorem, and it does hold up that on these triangles, the leg was 3. Well, the hypotenuse, we took that and multiplied the square root of 2 on there. So this leads us to a theorem we actually have that we just proved through a lot of repetition. In a 45-45-90, we call it a 45-45-90 because that refers to the angles, okay? Because if these 2 sides are congruent, what do we know about these 2 angles? They have to be congruent as well. And what would both of them have to be? 45 degrees, because this right angle is there. So the other 2 have to add up to 90. So in what we call a 45-45-90 triangle, or an isosceles right, the hypotenuse, or you could abbreviate as hype if you wanted, is square root 2 times as long as each leg. Does it matter which leg you take? No, because they're the same. Okay, now, I want you to draw this little diagram I'm going to draw in here. I call it like a road map. So let's say we call this leg X. What else do we then know? The other leg is X. Okay. Okay, then you can draw the congruent symbol. Okay. Now, how would I go from either leg? Let's say I want to go from this bottom leg. How would I get there? How would I go for the hypotenuse from the leg? What operation would I do? I'd multiply by the square root of 2. And so that makes the hypotenuse what length in this scenario? X times the square root of 2. Not double. Multiply by the square root of 2. The square root of 2 is not 2, so it wouldn't double it. Now let's say in some random universe, I wanted to go back the other direction. I have the hypotenuse, and I want to get the leg. How would I do that? Divide. Why? How do we know why we divide? Opposite of multiplication. And what would I divide by?
Square root of 2.
Square root of 2. I want you guys to draw this little road map on here, okay?
Dividing by the square root of 2 is the same as multiplying by just the same as squaring.
Say that again?
Isn't dividing by the square root of 2 just the same as squaring?
No.
No?
No.
That makes the 2 left over.
No. Because if we squared it, it would make it bigger. Because squaring something makes it bigger unless it's less than 1.
Yeah, but
That's weird.
wouldn't it would cancel out the square root of 2. So
Oh, in this case, yes.
yeah.
So, what happened mathematically here, you don't have to write this part down if you don't want to, this next part. If I were to take x times the square root of 2, the hypotenuse, and divide it by the square root of 2, what's anything divided by itself?
X.
1, and so then I'm just left with x.
Yeah, we let X out.
So in those cases, they divide out.
The thing that's not the
Questions on that? I'm going to try example 1a and example 1b.
Without using Pythagoras.
And then try not to use the Pythagorean theorem. So on example 1a, well, the other leg's 18, but we don't necessarily need to know that. How do I go from the leg to the hypotenuse? We just said we do what? Multiply by the square root of 2. So we just literally write 18 times the square root of 2. Can we do anything more with that?
No.
And leave it in simplest radical form?
Yeah.
No. The only more we could do with that is to make it approximated, but we're not wanting that. We can approximate it by putting it in our calculator, but we don't want that.
That'd be like a really big 36.
Well, you did it
Then you
wrong.
multiplied it by regular 2 instead of the square root of 2.
Probably square root of 18 and then both times 2.
All right. On example B, we know the hypotenuse. How do we get back to the leg? Divide by the square root of 2. So we're literally just going to start off by writing that. 18 divided by the square root of 2. Now, we talked the other day. Do we want that radical in the bottom? No. So what do I have to do to get rid of that?
Multiply it to the top.
Multiply by 1. Okay? Because 1 wouldn't change the value, but we're going to make 1 look different. How is 1 going to look in this case?
X.
Yeah, the square root of 2 or radical 2 over itself. Because that's secretly 1 because it's divided by itself. So it won't change the value mathematically, but it will change how it looks. Because 18 times the square root of 2 is 18 times the square root of 2. What is the square root of 2 times the square root of 2?
2.
Normal 2, the square root of 4, which is normal 2. Because you multiply 2 times 2 and get square root of 4, which is normal 2. Now, can we simplify the 18 and the 2 now?
Yes.
Yeah.
Yeah, and what would that give us?
9 and 1.
9 over 1 and the square root of 2, right? So that is our leg, 9 square root of 2. Yes.
Where did we get the 18 and the square root of 2 divided by 2?
You take this when we multiply by the square root of 2 or square root of 2, and you multiply straight across. 18 times square root of 2, square root of 2 times square root of 2 is normal 2.
Oh, yeah.
Okay? Any other question on that? A way you could verify your answer, multiply this by square root of 2 to go back to the hypotenuse. You'd have square root of 2 times square root of 2, which is normal 2. Multiply that by 9, you get 18.
Wait, what's this?
Wait, what's it?
This is 7 point thing.
That's confusing.
No, this is 7
A
point
little
thing.
bit.
How we go back?
It's not that confusing. It's just.
It hurts.
Yeah, it hurts.
Yeah, it hurts.
I use a different way than I
Your
use
toe or your brain?
Oh, both.
Okay.
If I had a
Well played.
It's actually my toes. Oh. Your toe.
Kaya.
Why does the square root of 2
No,
divide
more than one is broken.
This? Is that what you're asking about?
No. So
Yeah.
we're dividing that, right?
Yep, but one's underneath the radical and one is not. So you can't actually divide those. You can't say that's 1 and 1.
Oh.
Because
it's like a.
they're not equivalent, because it's not divided by itself. Yep, great question. Because this is particularly like 1.4 blah 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 forever.
So the exponent.
One second, Aiden.
Does that mean 9 is it's 9 the square root of 2 over 2 and the 9 isn't over it?
It'd be over 1 because this is multiplying together, not adding. If this was adding or subtracting on the top, then you're right, we'd have to split the fraction before we simplify this. But because it's multiplying on the top, we're able to divide multiplication. But we can't divide addition.
Oh, okay, I see.
Yep. Saren.
So the square root's kind of like a secondary exponent.
Square root actually is an exponent. It's actually the exponent of 1/2.
Okay.
But we're not going to get into that in here. Kelly, have you done the fractions? Yeah, those are fun, right? Yeah. Yeah. As long as you know what it means.
I'm screwed.
Yeah. All right. Any other questions on this, guys? Say that again.
What happens if the exponent is 0?
Then if the exponent is 0, you actually just have 1. Like, so it's literally anything to the power of 1. So like 5 to the power of 0 to me. Anything to the power of 0 is 1.
Why is that?
Then it's just 5.
Because mathematically what actually happens there, just to kind of deep dive into this, is let's say you have 5 to the 5th over 5 to the 5th. Mathematically what happens in all of this is you have the same thing over itself, right?
Yeah.
And so you'd end up getting 1. Now, the other thing that happens is you have, we have this shortcut rule where when the same base 5 is to exponents, you subtract those exponents. So you do 5 minus 5 and get 0. So it's both 5 to the power of 0 and just normal 1. So they are actually equivalent.
That makes no sense, but okay.
Because we have a shortcut rule to like where like maybe like x to the 3rd over x squared is x to the 1st. Because you can subtract those exponents. Just like when you're multiplying x to the 3rd times x squared, you add the exponents to get x to the 5th. So multiplying bases, the same base you add the exponents. Dividing the same base, x, you subtract the exponents. So here 5 minus 5 is 0, but it's also 5 to the power of 5 to the power of 5 over 5 to the power of 5 would also just be 1 because it's divided by itself.
But wouldn't it be 0 divided by 0?
No.
No.
Yeah. So anything to the power of 0 is just automatically 1. Pretty handy. All right. Anyway, that was a bunch of extra stuff. Okay. We are actually going to stop here in our notes today. So that way I don't give you guys the homework with like 2 minutes left. So I'm going to give you guys the first part of this homework, and then we're going to kind of second half it again next time.
24.
So I'm going to do numbers 2, 4,
I don't even do one.
5, 7,
Why does 8 have a star next to it?
9. Sorry, right down here. Bottom left hand corner.
Triangle next to it? But it literally does.
Get out of your problems.
12,
12.
14, 15, and 17.
Why not 18? We want to do 18.
Oh, yes. Actually, 18s I don't do.
What about 8? Should we do that? It's
Yeah.
not up there. It's not up
All right. So these are the problems I want you to do. See, is that 9 of them? So just over half.